We're about to get started. We have a special session in here. One of our other speakers hasn't been able to make it, so now we have a special edition AMA with Thomas, 10 years of Cilium. It's a really long time. So let's go back to 2015, a decade ago. When you started out the project, what problem were you trying to solve with Cilium?
Quite simply, we wanted to provide a better container networking solution. We all came, or we're currently working on networking and security for virtualization. Most of us on Open vSwitch, and then Docker happened. Many of us had seen Solomon's keynote and original Docker demo. I was like, wow, containers are happening. This will need new networking. This will mean a new level of scale. This will mean new requirements for security. Let's tackle networking for containers. So actually, we didn't focus on Kubernetes in the beginning. We focused on Docker.
Okay, and so Cilium has been open source since the first commit. How long did it go from that first commit until something you could actually put in the hands of users and feel kind of proud about and have them have some value out of it?
I think originally we thought this will take months, and then it took years. I remember we had a very early version of Cilium, excited, hey, we can ping between two containers. We did it. This is amazing. Let's go pitch Facebook. That's kind of how we thought the world would go. It was IPv6 only, no IPv4. Yeah, I was yes, there you go. Very excited, IPv6 only person. It was yeah, this is the future of container networking. Everybody will jump onto this. And then there was some excitement, but obviously nothing actually happened for quite a while. And it was multiple years until, I would say, at scale, customers and users actually drove value from it. And today, where we have massive customers and massive installations and still empowering tremendously large clusters, and clearly there is value being derived from that. But it was a long road. It was a very challenging long road to get stable enough, complete enough, and to hit that, I would say, trade-off where the investment to change your networking layer is worth the value that you get. That's a very high bar to achieve.
Yeah, so long journey, a lot of ambition at the beginning. Did you have any backup plan in case this whole eBPF or Cilium thing didn't work out?
Not at all. I mean, we were incredibly convinced, and I think this is true. I think for the whole core team, I think all the people that joined or all the developers that joined, as part of Isovalent or just outside contributors as well, total believe eBPF will change the world, and it has changed the world. It has absolutely changed the infrastructure world. So there was no backup plan. We were 100% convinced, and I think that's probably a requirement to have the endurance. To me, it's a little bit similar to if you don't have the total confidence, you're probably not going to finish that marathon. I think it's quite similar. You need that total belief. You need to feel that you're onto something, and you need to push through lots of tough times.
Yeah, definitely. So a lot of challenges along the way. A decade in the making. In this journey, what do you think was the hardest architectural or technical decisions that you had to make?
That's a tough one. Maybe this question. No. I think what was the hardest one? I think one of the hardest one. I think this is and this is still open. About midway through our journey, Kubernetes was super well established already, and then Istio happened. Right? And Service Mesh came around, and there was a time in which how is network for containers going to look like in the future? Is it going to be all just Service Mesh? Is it going to be some combination? And we had long discussions for, I'd say, 2 years in total. How are we going to change everything and go Service Mesh? Is this going to happen? Should we stick to what we have and see this more as an incremental step? And that's what we ended up landing on eventually. With Service Mesh is bringing in a lot of interesting new concepts. It is bringing in, for example, mutual authentication. Let's adopt these principles, but without actually changing everything and redoing everything. I think that was probably the toughest overall architectural decision, because there was a lot of pressure to, hey, Service Mesh is here. It's been created by the creators of Kubernetes, clearly this is going to change everything. You should change to that as well. So I think probably that. But it's a hard question to say what exactly was the hardest one.
Yeah, so service mesh, obviously, big discussion for a couple of years. You had to walk back IPv6 only in Cilium.
Yes. It took us 9 months to get to IPv4, yes.
Wow, fastest migration we've ever heard of. Were there any other moments along the Cilium journey where you were like, this might not work out?
I think not for the overall project. I think because we had incremental traction along the way. I think we had several milestones. For example, when Google adopted Cilium for GKE, that was a big milestone, lots of validation. So we always had these milestones along the way. But clearly there has been moments where we thought we have been completely wrong. I remember being at KubeCon 6, 7, maybe even 8 years ago talking about multi-cluster. And it was like, no reaction. I was like, how is this possible? Clearly you all need this at some point. But then for the first 2 or 3 years, there was just no interest in this. There was no interest for multi-cluster networking. The overall ecosystem was just not ready enough to think in multiple clusters. Everybody was had their own tooling, and then all of a sudden it exploded. And that's just one example. This happened multiple times when we thought we had the future figured out and you all need this, and then it turned out to be several years too early.
So you've contributed a lot to Cilium. In fact, you're, I think, in the top 20 all-time for CNCF. So you've contributed a lot of code and commits to the project and the ecosystem as a whole. Looking back, what are your best and worst architectural decisions?
Now you want to expose me right here. Best architectural decisions. I think one of the best overall and it's clearly not my decision only, but I think as a team when we said we're going to bet big on Kubernetes and change everything, and Kubernetes API is the default for everything we do, I think that was a good decision now in hindsight. Because that was not obvious back then when we made that decision. It was very much, I think, the world of the Docker ecosystem and the Kubernetes ecosystem were head-to-head, and we had to make a call what we focus on architecturally, and we focused heavily not just on the Kubernetes API, but also its principles. And we have adopted this not just for Cilium, but for everything we do. So when even for commercial products that we have today, we push that Kubernetes thought model into all aspects of what we do, inside and outside of Kubernetes. I think that's been a good decision overall. Worst decision has to be something CI related. I feel I think the CI is one of the aspects where I think there is no matter how well you think you do it, a year or two in, the team hates it, and you end up gonna redo everything. And it's also something that if it's frictionful, it has a massively negative impact on your entire team. So I feel like what feels like the wrong decisions have all been around CI and how we do CI, and that's at least where I see most of the unhappiness about a particular architectural design.
Okay, so that's good and bad design decisions. Originally, eBPF and Cilium were just in networking. Now they've expanded to observability and security, and who knows what's next. What kind of additional use cases are you most excited about that are kind of beyond the original scope of Cilium?
I think, eBPF as a whole has evolved into an overall, almost like an infrastructure language, because it can run on Linux and now Windows. So we can provide these infrastructure services, whether it's networking, security, observability, hidden in the infrastructure. One very exciting use case where we reapplied what we have done, in particular with Tetragon, is as part of Cisco. So for those that don't have this context, Isovalent was acquired into Cisco about a year ago. We're now using eBPF to secure all Cisco equipment. So eBPF runs in switches and routers and firewalls, and when these devices, they're all Linux-based today, when they have vulnerabilities, we use eBPF to mitigate that. And that's actually a wide-scale, industry-scale application of eBPF to enhance security. Incredibly exciting. And now I see this not just as part of Cisco equipment, but into IoT devices at large, whether it's your heating pump at home, that actually is very vulnerable. And it's running Linux, and it's not well maintained. It hasn't been upgraded in 5 or 10 years maybe. Full of vulnerabilities. It's hooked into your Wi-Fi. What could go wrong? So I think that's definitely something that excites me, how we can bring this to protecting IoT devices. It's pretty clear that vendors on their own, building the hardware, don't always have the necessary expertise to actually do the software part. So it would be great if we could bring our expertise in here and make the overall infrastructure world a bit more secure.
Yeah, absolutely. eBPF is really taking over the infrastructure landscape. In kind of the same way, the Cilium community is kind of taking over. So we now have over 1,000 contributors to Cilium. You had the first commit, and then the Isovalent team built a lot of it. Do you remember who the first outside contributors were that didn't come from Isovalent?
I should know this, right? So I mean, I remember many phases, and we ended up hiring quite a few of those that obviously started contributing to Cilium back then. So many of them became Isovalent employees. Who was the first one? It was probably not Eloy. It was, I think his GitHub handle was scanf or something.
I think I remember you, or maybe it was Joe telling a story about how you would have the weekly Cilium community meeting, and it would just be Isovalent people having the internal meeting publicly. And then one week, somebody from, I think it was Google, showed up, and we were like, woo, let's go.
Yeah, okay.
So that's the one that I've heard before.
Okay.
So, and yeah, kind of from that beginning, Cilium has grown into one of the largest projects in the cloud native ecosystem. As kind of the creator and maintainer of one of those projects, what kind of knowledge would you pass on to other maintainers in the ecosystem?
I think open source can only be done if you really believe in open source. I think that's a core fundamental. Unless you 100% buy into that, the community will not buy into this. And I think this may be advice specifically for those that also want to build a commercial model around it. You have to fully commit to the open source part. If you kind of not fully commit and it becomes obvious that you are not, or maybe holding something back early on, then the community will not commit, and you will not get the commitment from others outside and not from your end users, and you will not get, I think, the excitement and the positive aspect, because from a commercial side, it's obviously harder to be commercially successful if most of your value is also available for free. So clearly you need to have a boost in, let's say, adoption, marketing, and so on. So that's great, but you need to fully commit to the open source way, and that, like, there's very little room for compromise there, because I think we're all purists on the open source side.
So talking about committing to open source, to the Cilium repo, do you know how many commits you have?
Me personally?
Yeah, you personally.
I have no clue, but I know I'm still at like number 2 or 3 or something like that. I think being overtaken by more and more people.
You're currently sitting at number 2?
Number 2, okay. I have no, 1,000 or something. I have no.
2,775.
Okay. So you could back in and get that to a round number or something.
Yeah, go take over Andre again.
All right.
So kind of along this whole journey too, we've talked a little bit about the technical side. What do you think has been the most surprising thing for you, like on the personal side?
I think I've been surprised by how widely adopted Kubernetes is today now. And I think with that, the entire CNCF ecosystem. I think I've only realized this when I now had a chance to get out of the Kubernetes bubble, because as Isovalent, we've very much been in the Kubernetes bubble, and like the CNCF and KubeCon are like, that's our bunch, right? And you know everybody. And now part of Cisco, all of a sudden you can talk to all the different customers and they completely new contacts. And then you all of a sudden realize that even in boring enterprises where you wouldn't expect it, Kubernetes and the thought of Kubernetes and the thought of GitOps is widely understood and desirable. So I think what we have created as a community is kind of a blueprint that will make big waves. That's been the most surprising to me, because I only got to see that when I had a chance to step out of the Kubernetes bubble, right?
Yeah, definitely. It's cool coming here and seeing all the people that are excited about KubeCon. I think at least every single time it's at least 50% new attendees, so lots of energy coming into the community. So in the course of your open source journey, I guess you've seen a lot of different ways that people have used Cilium in either good or bad ways, depending on how you look at them. What do you think is the funniest or strangest use of Cilium that you've seen?
I mean, I've seen exciting projects like running Cilium on Raspberry Pis. I think there have been examples of using Cilium to run like massive gaming multi-cluster systems, like people implementing IPv6 only ideas and like really pushing the limits, right? What is the funniest one? Is there something funny about Cilium? I don't know. So it's a tough question. I actually don't know. Like, what's the funniest one? Nothing comes to mind here. 5 minutes, all right.
Yeah. I think it's 10.
All right.
Yeah, it's okay. You know, we're all fast and loose here, just like this talk.
Yeah. So if you think you have a funny Cilium deployment, hit me up. I would love to learn about it.
Okay. We all know that one of the hardest problems in computer science is naming things. Besides the terrible name of eBPF, what do you regret naming the most?
And naming is always hard. Consumable. Yeah. So this was a consumable. This is Joe. Yes. So this is so this is an internal component of Cilium that as an end user you're not exposed to. But this is a very bad name I'm responsible for some Golang interface. It was so bad that it was put onto our fridge in the office. So the fridge became the consumable, because I was apparently the only person for whom consumable made sense. Everybody else was like, what is this? What is a consumable? It was me trying to be object-oriented design architect and trying to name something. Yeah, so probably Joe is the best judge of this. Consumable it is.
Okay.
And second one would be mesh. Like the Cilium mesh, we would name differently today.
Service mesh, Cilium mesh, cluster mesh.
In our defense, Cilium mesh was named before service mesh came around. But yes, the moment that happened, it was like, oh, we should have named that something differently, because obviously it was confusing to everybody.
Yeah, so we've talked about the past, the present. Now let's dive a little bit into the future. What's something kind of looking forwards that still keeps you up at night about the project?
Well, fortunately, nothing really keeps me up at night. So that's the good news. But what are the things that I'm concerned about? I think there have been, and this is changing over time, I think, for example, throughout the acquisition process into Cisco, we're obviously very concerned, and like it was extremely important to us that the open source project would not get damaged from this. Like this was, I think, priority 1, 2, and 3 that we cared about while we discussed and aligned with Cisco how this acquisition would happen. And I think we had a very positive outcome on this, that the open source project is not negatively impacted in any way, continues to run on this openly governed. So that concern is gone. So I think the next one would be, I've been in the software industry long enough that I know everything has a cycle. Like you mentioned, it's 10 years in. So there's a couple of projects I've been involved that have a very long duration, such as the Linux kernel. I have a kernel development background. But for most other open source projects, it's vaguely between 10 and 15 years for the ones that are successful. So either Cilium is like the Linux kernel, or we have to make sure that we not stop the innovation and actually continue pushing. And for example, looking at AI infrastructure today and see how does Cilium help maybe companies adjusting technologies from neoclouds or building their own AI infrastructure or running AI agents or running AI workloads, how we can help there, because otherwise what we've built will eventually become obsolete. That's just a rule of technology. I think as one of the creators of the project, that I do care about that what we've created provides value for as long as possible.
So I think that also ties well into the next question. So that was what keeps you up at night. What gets you up in the morning and makes you excited about the next 10 years of Cilium? What are you most looking forward to?
I think it's the exciting ecosystem we have created around eBPF. Overall, like Cilium is obviously a huge part of that, but also Tetragon and all of the other eBPF projects that have been created. I feel like that is a really long-term movement where we can continuously drive more and more, I would say, exciting ideas from it, and it will continue to spark new projects, new directions. So I feel like there's so much potential left that we can still tap into. That's super exciting. And I think it also gives a lot of room for others to grow into and implement their own ideas.
And the last question I have before opening it up to the audience, if you could go back 1 decade ago to 2015 Thomas, what's the single piece of advice that you would give him?
Don't worry too much about things in general. I think trust your gut feeling and don't worry too much is what I would say. But that's always easier said in hindsight than actually believing it.
Okay, nice. And we have a couple audience questions. I know, Hermant, you had a few?
All right. So a couple of eBPF questions. So the first part is, what upcoming improvements in BPF are you really excited about? And 2, we've done like networking, security, observability. You can also do scheduling now with SchedXT. So will we have a scheduling thing with Cilium or a new project? Yeah.
Let me answer the first one. The second one you'll have to clarify because I'm not sure I fully understood it. So the first one, eBPF, excitement on eBPF. First of all, I think eBPF coming to Windows is exciting because I think it brings an opportunity that we can tackle entirely new fields of problems, such as better endpoint security overall. Right now, with Linux only, great for server workloads, obviously like extremely wide penetration of Linux there. But if we're talking end user devices, as an example, laptops, VPN solutions, endpoint security solutions, Windows support is a necessity. And I think that's exciting because that opens up new fields that are ripe for innovation. Right? And I think eBPF will play a key role in there. And then also the overall ecosystem becoming simpler to use as well. I think that is, I know that this is really, really hard, but I know that the eBPF community is focusing on this. How can we build abstractions? How can we lower the barrier so you don't need to be one of the top 1% kernel engineers to actually use eBPF? Which is, I think maybe as a company was sometimes in our favor, that not everybody was able to just replicate what we were able to do, but I think for the success of eBPF for a while, we'll have to lower this barrier. And the second question I didn't quite catch.
So SchedXT is this new feature in the kernel that lets you customize the kernel scheduling behavior, right? So would we ever implement like an easy to use custom scheduler thingy in Cilium?
Absolutely, yeah. I think this is not just necessarily limited to what is available through eBPF. I think, for example, Cilium also has bandwidth management capabilities that are configuring the QoS layer of Linux. Obviously, if there is a BPF extension, an API that makes it simpler to even, I would say, make things more cloud native. I always saw Cilium as a kind of a translation layer to make the Linux kernel which on its own is not aware of containers or cloud native or does not know what Kubernetes is. If you grab Kubernetes in the kernel code, it will show up, right? But Cilium through eBPF essentially makes the operating system cloud native and aware of containers and aware of Kubernetes. And I think we'll see more of that. Scheduling is one such example.
Cool. I have more questions. But yeah.
Don't worry, it's not an IPv6 question.
All right.
So in general, like what I wanted to ask is, what are your thoughts on like everything? If you look around, like that's in the Linux kernel, that you know. When you deploy an application, you want logging, you want monitoring, you want visibility, you want security, right? Now you want networking. What's already present in the Linux kernel, do you think we are reinventing that wheel with eBPF by adding all those things like back in the eBPF thing?
Yeah, absolutely. Yeah, so that's what I meant by eBPF is the infrastructure language. Absolutely. So I very much see it as 25, 30 years ago, everything was ASIC hardware, hard-coded. Then we had an age of like software-defined infrastructure in general, whether it's networking and storage and so on, where we re-implemented things the same way, but using virtualized appliances like virtual switching, virtual routers, virtual firewalls, and so on. And eBPF, through the needs of containers running on the same operating system, we had to bring that back into the operating system. So I think I very much see containers step one, but now AI even more, the need for the infrastructure and thus the operating system to provide all of the infrastructure services that you have just mentioned. So absolutely yes. And I see eBPF being the abstraction of this that actually enables this. So we're not becoming vendor specific. We're not locking ourselves into specific vendor APIs.
The other question I have is, do you ever see a future where eBPF or equivalent to eBPF would be available on operating system other than just Windows and Linux, like BSD, for example? Right,
Yeah,
like
yeah.
that's a completely different architecture, get it, but
It's a slightly loaded question, right? Because like the whole naming around eBPF, there is naming-wise ties back to BPF, which originally obviously comes from BSD and so on. Even though code-wise, it would be wrong to say that eBPF is an evolution. It was essentially something new and then had to get renamed to eBPF so it could, and then support for classic BPF was added. So I think, does it make sense to extend? I think yes and no. There's some of these have been tried in the past. There's, for example, there's an eBPF user space implementation. But then again, what's the point in that? The whole point of eBPF is that you're well integrated into the operating system, which you cannot change. And it's something that you don't want to change in any insecure way, because if you change it in a way that it crashes, you lose your whole server. That's the whole point of eBPF, and why you're not just using something like WebAssembly or Lua or just native code. So I think, does it make sense? Yes, but it really depends on each use case where this extension of the operating system is needed.
thank you.
Any more questions? How much time do we have?
I think we're out of time.
Yeah.
So with that, thanks, Thomas. 10 years. Looking forward to the next decade.